Welcome to our lesson 3.7, something called the empirical rule. And it's just going to deal with the percent of data that are how many standard deviations away, depending on what we define it as. We're going to look at 1, 2, and 3 standard deviations away. So if we wanted to identify the amount of data that is within 1 standard deviation as a percent, that's 34 plus 34. That's a total of 68. And if we are 2 standard deviations, that's the 68 plus another 13.5 and 13.5, total of 95% of the data. And then when we look at 3 standard deviations away, where that's going to be everything added up between these spots here, that's 99%. So sometimes you'll see percents, the precision we have here, sometimes you'll see 99.7 for this. But for our purposes, we're looking at 68, 95, 99. That rule is called the empirical rule. It's where most of the data sits. So let's look at some problems and see how this applies to some problems. Looking at each problem here, we're going to want the standard deviations 3 away from the mean, and we're going to label them by the amounts or the values. So the mean score, in this case, ACT, you get a value between 0 and 36. The mean score is 21, so our middle is 21, and then for each standard deviation away, it's worth 5. So adding 5 gets us 26, 31, 36. Subtracting gets us down to 16, 11, and 5. Okay. Now you can see 100% of the data needs to exist from 0 to 36. So our curve must not be an actual perfect bell curve, but it works pretty good for what we're trying to do. What percent of the students scored higher than a 26? We find a score of 26 and we add up those percents. If you add those up, 13.5 is 14. 14 plus 2, we're calling it 16% of the data. So you're in the 84th percentile if you score a 31. That means 84% scored below, 16 above. What percent of students scored below a 16? That's a value of 16. That's going to be the sum of the 3 standard deviations, or the 3 that we have here. And that's going to be, again, 16%, kind of a coincidence. 68% of students, back to the empirical rule, that's going to be 1 standard deviation away, scored between 1 standard deviation below and 1 standard deviation above. Okay. Another problem, the mean height of a man in the US is 70 with a standard deviation of 3. So I'm going to go with this one as men. I'm adding these standard deviation amounts and subtracting. And then for women, 64.5, where we add a standard deviation of 2.5. So adding 2.5, let's see if I get these right, 67, 69.5. Another 2 to that is 71, so 72. And then down subtracting 64.5 minus 2.5, 62, 59.5, 57.5. All right. I'll just write it again down there. All right. What percent of men are taller than 67 inches? So this value here, this graph here, this is, I'll say this is women and men. We've got to make sure we look at the correct graph. For men, higher than 67 is going to be, if you do the math on this, obviously this is 50% of the data here to the right, plus another 34. Or if you look at just these, this adds up to 16 down here. So that's a total of 84% are taller than 67 inches. 95% of women are between which values? That's back to our empirical rule here, that's going to be 2 standard deviations. So that's from here, 1, 2, and 2 to the right. So 59.5. You should try doing these problems before seeing the answers, so you can pause and get those answers. Tony is 73 inches tall. Darla is 69.5. Who is taller? Tony being compared to other men, or Darla compared to other women? So we're going to look at the percents for each of these people and see who is in a higher percentile. So for Tony, if he's at 73 inches, that means he's at the 84th percentile. So Tony is at the 84th percent. That means 16% are taller. He's pretty tall relative to other guys. And then Darla at 69.5, she's right in the middle. So that's 50%. She's at the 50th percentile. So Tony being at 73 is slightly higher than, oh wait, I misread. 64, not 69. So actually Darla, gonna write better than I do. Darla's actually up here. So she's, this is 84 plus another 13.5. So basically Darla is at a higher percentile. That's going to be, this was like 2.5% down here. So 97.5%. So Darla is a taller person relative to other women. Moving on to this question 3 then. Minnesota's daily high temperatures follow a normal distribution in the winter. Average temp is 35. And 4-degree standard deviation. So if I go 1 above, it's going to add. If I keep adding, I get these values. If I subtract, I go down to 31, then 27, and then 23. What percent of the days would have a temperature between 31 and 43? 31 to 43, that's going to be the 34 and 34, or 68, plus another 13.5. So that's 68, 78, 81.5. So 81.5% of the days are going to be accumulated between 31 and 43. Is it possible to have a 48-degree day in Minnesota? It is possible, but it's very unlikely. It's in the 0.5%. So yes, but unlikely. On January 1st, the high was only 24 degrees, so that's somewhere in here. Remember, this is a 0.5 and this is 2%. So in order to find out the percentile for this, what we can do is do kind of a proportion here. So we know we have 0.5% that are lower than 23, and then 24 is one of these 4 degrees. So that's a fourth of this. We can add a fourth of 2. So that's a fourth of 2 is 0.25 times 2, which is half. So a half plus a half, we have a 1% chance of that occurring. And that's an estimate because the days actually tail off as we get closer to 23, but 1% is a good guess. Which interval will contain more days with these temperatures? 31 to 39, that's our middle there, that's 68%, 1 standard deviation. 27 to 35, that's still 2 standard deviations, but we're not picking up that big amount to the right of this, so this is going to be a 34 and a 13.5, so 47.5%. So this one's not it. 35 to 43, again, 47.5. So our correct answer is right here. And then finally, the average high temperature in Chicago in the winter months is 38 degrees. So it's a little bit warmer. Could be lake effect. So 38 as opposed to 35 in Minnesota. 3-degree standard deviation. So we're going to be adding and subtracting 3. 3. And then subtracting. Okay. Now when we look at the amount of days, and it's kind of curious here, this 47 and 47, they're the same, so they're going to have the same percentages, but that happened because this standard deviation is only 3 degrees, and the standard deviation up here was 4. So it's a little more spread out for Minnesota. The average high temperature Chicago, we did that. If both places recorded temperature of 44 degrees on the same day, which location is hotter in comparison? This is kind of like Darla and Tony, I think it was. So let's do a quick comparison here. 44 degrees. This will be, this is only 2.5. So for Chicago, that's in the 97th and a half percentile. For Minnesota, 44 degrees is somewhere in here. Okay, I'm going to do that same proportion thing. 1/4 of 4 degrees, well, that's 1. So we got a total up here of, this ends up 97.5 plus another degree, so 98.5% for Minnesota. So it's less likely, you're in a higher percentile in Minnesota for a warmer day than in Chicago. Okay. All right. That covers quite a bit of stuff. Hopefully that makes sense. We can talk in class.